So hello, today the topic is operating system structures. We are going to see the 5 types of operating system structures which has evolved through times. This includes the simple structure, the monolithic structure, the layer structure, the microkernel structure and the modern structure. This a simple design. It was initially given where the application programs is directly accessing the ROM BIOS device drivers. Here, this is the hardware. Since you see there is a direct access from application program or resident program to the hardware, it makes the system vulnerable. Hence, if there is a single crash, the whole system crashes as well. Hence, this was next proved to monolithic structure. In monolithic structure, you have two parts. That would be the kernel and the system programs. Here the kernel is separated through a series of interfaces and device drivers which have been added and expanded later. Kernel provides these all the systems like file systems, CPU scheduling, demand paging. These are all the services provided by the kernel. The disadvantage here is that suppose you have any kind of fault, when you call the system calls for resolving that, each and every program present over here will also be disturbed, and this can also lead to a complete crash of the system. This is why we had a layer structure. Here the problem was these services are not segregated properly. So in layer structure we have all different layers. Each layer has a complete certain kind of services to provided. Here the zero layer is actually the hardware. The advantages here is the communication, the ease of communication and maintenance. Since we know all the complete kind of certain kind of services in each of the layer, we have a easy maintenance. Now when it comes to debugging, you will be starting from the layer 1. Since assuming that the layer 0 is completely perfect, you start with the layer 1. In layer 1 you start debugging and slowly approach the next layer. In layered approach, the thing is the lower layer will be providing the services to the upper layers. So here is an example I would like to say. It is like I told, the lower layers actually give services to the upper layers, which means device driver for backing store must be at a lower layer than the memory management routines, because the memory management requires ability to use the backing store. Here, so this was actually a specific example where I specified that the lower layer is giving services to the upper layers. So if you ask for a disadvantage, it is a little bit inefficient. The user program executes the IO operation and then it executes the system call which is trapped in the IO layer. This calls again the memory management and then calls the CPU scheduling layer and pass to hardware. So you see the complete process. This complete process is actually leading to more overhead. Hence that is one of the disadvantage. Although each layer is implemented with the operations provided by the lower layers. Like I gave you the previous example of device drivers, right? So that is how it is done. And next, each layer will be hiding the existence of data structures and operations hardware from higher level layers. So here you have that hiding mechanism. Not each and every display of information is required. The only ones that is needed is done. The operations will be done, like how it is done is not given. Now we come to the microkernels approach. In microkernels approach, the basic idea is to shorten the kernel. This is the microkernel. Come little forward. This is the microkernel. This is the microkernel and these are the client programs. So what we do is we remove the non-essential programs, non-essential components from the kernel and implement them as system and user level programs. So you have the shortened kind of kernel, and this is actually portable to any kind of hardware provided. As I told, this results in a smaller kernel. It provides minimal process and memory management and communication facility. And here the main thing that should be noted is in communication you will have the message passing. So this is actually a disadvantage, since the message passing takes a lot of time. In the sense, the program, one process has to go to the kernel, the kernel has to then give the information to process 2. So that is how it goes, and it requires more time, and the usage of CPU also increases. So yeah, it is that is one of the disadvantage. And here the client programs are actually the communication between the client programs is how actually the message passing is used here. And suppose you have new services, those are added to the user space, this area I mean. So next comes the modules. In modules, this is a loadable kernel module. Like this is one of the example, Core Solaris kernel. In this you have different kind of modules. They like scheduling classes, file systems, loadable system calls, executable formats, streams modules, miscellaneous, and device and bus drivers. So these are different modules. Here what exactly the idea is, the theory behind is, here this is the main core. Now you want to add more services to it. What you do is you keep on adding it here. And that is how suppose you have in the future days or in the forward days you have to add more services, many new technologies or many new kind of things, then you can add in this way, which is far more better than this kind of process. Because in microkernel you see, you don't exactly know what are the essential programs and what are non-essential programs. There is a bit of, you can say, clash, like what should be there in the core kernel and what shouldn't be there in the core kernel. But here you keep on adding, which is actually a benefit. And modules, it is actually said that it is a combo of both layered approach and microkernel approach. If a service is required, then a module is loaded during the compile time or runtime. So yeah, when you require a service, it is loaded during the compile time or the runtime. Each kernel section is defined by protected interfaces, but more flexible than layered system, because any module can call any module. So yeah, this point basically means here any module can be calling to any other module as well. These are, as I told, it is a combo of layered structure and microkernel. Here this modular service is given, and then it is more flexible than the layered system as well. So yeah, this link service is dynamically preferable to adding new features directly to the kernel, requires recompiling kernel every time the change is made. So yeah, the another point what is given is, every time you make a change, you have to recompile the kernel, because you are adding a new service, right? So this requires recompiling of the kernel. But if you go and see the history of the structure of operating system, it was first simple structure where we didn't exactly have proper definition of services. It was all mixed. And the example for that was the MS-DOS system. MS-DOS is how it implemented. Next comes the monolithic. Here we have different structure, like different segregation. Like this is the kernel. Here you have the system call, which is the interface to kernel, and you have kernel, which is interface to hardware. In the sense, it is not directly contacting. These are the interfaces. So that is how monolithic is given. They have divided it in two parts. But here you saw that there are problems where if you want to change any single program, you have to completely change it. The kernel completely gets disturbed. So which is why we had a layered approach. But in layered approach, again you see there is overhead. Right? When you keep on calling the system calls again and again, you have overhead here. And then you get the microkernel, which is much better than layered kernel, since you have a smaller kernel. But again here, you will be having the disadvantage where you don't know what exactly problems are essential, which are not. Because here in this area, the inter-process communication, CPU scheduling, these are actually the important essential programs that we have put in the microkernel. And next you get the modular service in modules, in terms of modules, where you have the approach of the combo of these two. And if we see today's modern examples and all, this modular approach is the one which is being used. And if you ask for any other examples for microkernels, you can say True6 for Unix and QNX. It uses microkernel for yeah. So yes, thank you.